Lecture 17 notes. So the first question is, solve each formula for the specified variable. So A, we're given this formula, S equals to 1/3 of A plus B plus C. We want to solve for C. So first, we want to get rid of this 1/3. How do we do that? We have an equation. We can always multiply by number on both sides. So we would multiply by 3 on both sides. Right? 3 times 1/3 equals to 1. Because 3 is 3 over 1. Right? 3 times 1 in the numerator is 3. 1 times 3 is 3 in the denominator. 3 over 3, that's 1. So we have 3s equals to 1 times A plus B plus C, just A plus B plus C. Now we want to single out C. So solve here means we want to isolate C. So we write C equals to, we subtract A, subtract B on both sides, or we move A to the other side, we move B to the other side. So I have 3s minus A minus B. So C now is solved. C is 3s minus A minus B. So similarly, we could solve for A, we could solve for B, right? We could see clearly A equals to 3s minus B minus C. And B equals to 3s minus A minus C. But for this question, we want to solve for C. So the answer is this one. So these two just extra, right? Just me telling you, if we were asked to solve for A, we get this. If we were asked to solve for B, we get this. Now let's see B. And we want to solve for R. So we see on the right-hand side, we have N times R times T. So we want to get rid of N and T. So how do we do that? We just divide by N and T on both sides. Because N divided by N equals 1. T divided by T equals 1. 1 times R times 1 is just R. So R equals to PV divided by NT. Similarly, if we are asked to solve for other variables, let's just try here. Maybe we're asked to solve for P. Then we just divide by V on both sides, right? We have N R T divided by V. Similarly, if we want to solve for V, we divide P on both sides. So N R T divided by P. If we want to solve for N, we would divide NT, RT on both sides. We get a PV divided by RT. If we want to solve for for T, R is solved. We would divide NR on both sides. So we get a PV divided by NR. All right, but for this question, we are asked to solve for R. So the answer is this. This is just extra practice, okay? Now let's see question 2. A company is planning to manufacture laptops. So fixed monthly cost will be 20,000. So that's monthly, so 1 month will cost 20,000. And it'll cost $20 to produce each laptop. So this is an extra cost, but this cost depends on how many laptops. So for 1 laptop, it costs 20. So we want to do A, B, C. A is saying write down the cost function C of producing X laptops. So we want to write the function C of X. See the cost in terms of amount of X laptops being produced. And of course, this is a monthly. Okay, we're not going to do yearly. This is monthly. So 20,000 is just one. So in a month, $20,000 is a fixed one-time cost. But we have to add the cost for produce each laptop. For one laptop costs $20. For X many, that would cost 20 times X. So get a linear function. So the cost function is C of X equals to 20X plus 20,000. We see this is linear function. It's like a slope intercept form, right? 20 is a slope. Slope measures the rate of change. Okay, now let's see B. B, we want to write down the average cost function, C bar. So C bar, the average cost of X equals to C of X, the total cost divided by how many laptops being produced. And the total cost is 20X plus 20,000 divided by X. And we can simplify this. Last class, we did polynomial divided by monomial. So we'll do 20X divided by X plus 20,000 divided by X. Well, 20X, X over X becomes 1. 20 times 1 is 20. So this becomes 20 plus 20,000 divided by X. So we see the cost function is a rational function. The total cost is a linear function. The average cost is a rational function. So C is saying for how many laptops must be produced each month for the company to have an average cost of 40 per laptop. So this means a C bar equals to, I cannot go down. Okay, I have to move up. So that means C bar of X equals to $40. So we know the C bar function is 20 plus 20,000 divided by X. So we just have to solve this equation, this rational equation. We subtract 20 on both sides. 40 minus 20, which is 20. Get a 20,000 divided by X. Now we multiply by X on both sides. X times 20, get 20X. This X and this X, X over X becomes 1. 1 times 20,000 is 20,000. Now we divide by 20 on both sides. So 20,000 divided by 20, that's 1,000. So the company needs to produce 1,000 laptops to have an average cost of $40 per laptop. Okay, now let's see 3. 3 is saying a passenger train can travel 240 miles. So this is a passenger train, can travel distance 240 miles in the same amount of time. Same amount of time it takes a freight train. So we have 2 different kinds of trains, one for passenger, one for freight. And to travel 160 miles, if the rate of the freight train is 20 miles per hour slower than the rate of passenger train, find the average rate of each. Okay, so let's first recall the distance formula. Distance equals to speed multiplied by time, right? Distance equals to speed multiplied by time. And if we solve for t, we would divide by v on both sides. That equals distance divided by v. Okay. So we want to form an equation. So how do we form an equation? So the key word is here. The two trains use the same amount of time. All right, so we're gonna do equation in terms of time. So on this side, we do passenger train time. On this side, we're gonna do freight train time. So how do we get time? Time equals the distance divided by the speed. So for passenger train, in the same time, it traveled 240 miles. What is its speed? We have no idea. So let's call it VP, or just a variable. So this represents the speed of the passenger train. And time for freight train is the distance that he traveled, which is 106 miles he traveled, over its speed. Let's use VF, to the speed of freight train. Now we have two variables, one equation that cannot be solved, right? But now this sentence tells the relationship between the two speeds. So the freight train speed, the rate of the freight train means the speed of the freight train is 20 miles. So which means VF means equals to 20 miles per hour, 20 miles per hour slower, less than the rate of the passenger train, VP. Okay, we have a system of two equations, right? So VF equals to VP minus 20. So we want to change this VF, right? We want to change this VF into VP minus 20. So let's do that. Let's erase that. Let's erase this VF. And we want to write as VP minus 20. Now we just solve this equation. Let me change to be blue color. Oops. I cannot change the color. We could do cross multiplication. It does not allow me. So I multiply 240 with VP minus 20. That equals to VP times 160. Okay, so 160 VP equals to 240 times VP minus 20. So then this side, we get 240 VP minus 240 times 20. Times 20, maybe I use parentheses, multiply by 20. So I'm not multiplying them because in the hope of in the future, I can do some consolations. So 240 minus 160. So we're going to minus 160 VP from both sides, or to move 160 VP to the other side, then becomes negative, right? 160 VP. Same thing, we're going to add 240 times 20 on both sides. 240 VP minus 160 VP, we get 80, the speed for passenger train. We move this negative 240 times 20 to the other side, become positive. So we have 240 times 20. Now we divide by 80 on both sides. So we divide by 80 on both sides to get a VP by itself. So the speed for the passenger train, well, let's simplify it. 0 cancel with 0 is same as divided by 10 in the numerator, divided by 10 in the denominator. Then 2 simplifies 8 to be 4. Well, 4 goes into 240 60 times, right? 4 times 6 is 24. So VP equals to 60 miles per hour. Then VF is 20 miles slower than VP. So that's 60 minus 20, which is 40 miles per hour. Miles per hour. VP is 60 miles per hour. All right, so what have we done? We use the formula time equals to distance divided by the rate or by the speed, right? Because those two trains, the passenger train and the freight train, use the same time, so we want to use distance divided by speed for the passenger train, same time equals to distance divided by the speed of the freight train, right? The distance the passenger train in the same time traveled 240 miles, right? And its speed, which is called VP. The distance in the same time freight train traveled 160 miles. And the speed we call VF. But then we're told VF, the speed of freight train, is 20 miles per hour slower than the passenger train. So we have this speed of freight train is speed of passenger train subtract 20. So we use this to solve, change the VF into VP minus 20. We cross multiply, right? We solve, so we get the speed of passenger train is 60 miles per hour, and the speed of the freight train is 40 miles per hour. Okay, now I need to erase some of this for number 4. Okay, now let's look at number 4. George can clean his garage in 4 hours. Oh, I need to change back to my pen. In 4 hours. What happened? Okay. In 4 hours. So that's the time George used to clean the garage. And his son can clean in 6 hours. So how long will it take them to clean the garage together? So looking for this time, working together, let's call it T. So this is work done. We have work done formula. So we consider work done as 1. And this can be anything basically, because in the end it gets canceled. It doesn't really play any role in the equations or in calculations. So why not to use 1, right? So 1 equals to the speed of working, the working speed, multiplied by the time. Or to see the speed equals to 1 over t, right? Or t equals 1 over v. But in this case, we want to use v equals 1 over t. So the speed of George is 1 over the time he used, which is 4 hours. So 1 over 4. That's George's speed. When they work together, we want to add both of the speeds. So his son used 6 hours. That's 1 over 6, right? The speed adding together is the speed when they work together. We call it 1 over t. Because it takes them to working together, it takes them t hours to finish. So the speed of working together is 1 over t. So we see this is a rational equation, right? We just have to solve this. So what do? We can multiply by 3 over 3, multiply 2 over 2. So we get 3 plus 2, which is 5 over 12 equals 1 over t. Cross multiply, 5t equals to 12. So t equals to 12 divided by 5, which is, well, 12 is 10 plus 2 divided by 5. 10 divided by 5 is 2 hours plus 2 over 5. We don't want to tell people, it takes me 2 hours, 2 hours and 2 over 5 hours to come to, to do something. So we want to convert the second one into minutes. The 2 hours is okay. So these 2 whole numbers just means 2 hours. We want to convert this into minutes. So what do? Each hour has 60 minutes. So we just multiply by 60. So 5 goes into 60 12 times, right? 2 times 12, 24. So this equals to 24 minutes. So this equals to 2 hours and 24 minutes. Okay, so when they work together, it takes them 2 hours, 24 minutes to clean the garage. Let's see 5. 5 will have 2 formulas. One is called direct variation. The other one is called inverse variation. Sometimes called, varies directly, or varies inversely. So if 2 variables varies directly, that's y equals to kx, or k equals to y divided by x. So we saw this is a ratio of 2 variables. So the constant k represents some constant. So equal the ratio of those 2 variables. So varies inversely means y equals to k divided by x, or k equals to x times y. You see this is multiplication. So if it's the inverse variation, the 2 variables multiply to be a constant. Let's check A, B, C, D. A is y equals to 5x, right? Y equals to kx, so k equals to 5. So this is varies directly. So this is direct variation. Y equals to k divided by x, or y equals to 5 divided by x, or 5 equals to x times y. So this is inverse variation. Xy equals to 12, inverse variation. Y equals -7 times x, direct variation, right? Simple. Let's see 6. If y varies directly means direct variation. So right away, in our head, we're thinking, okay, the formula is this, y equals to kx, or k equals to y divided by x, all right? This thing, when y is 10, x is 2. When y is 10, x is 2. So k equals to 5. So that means y equals to 5x. Now this is finding y when x is 7. Well, y 5 times 7. 5 times 7 is 35. That's it. So when x is 7, y is 35. Let's see 7. The object's weight on moon, m, use variable m, varies directly as its weight on Earth. We call E. So right away, we write the formula. So m equals to k times E, because it varies directly, means a direct variation. Or we can write k equals to m divided by E. An astronaut's weight is 360 pounds on Earth, right? That means astronaut on Earth, 360 pounds, then corresponds to 60 pounds on the moon, corresponds to 60 pounds on the moon. Simplify this, divided by 10, divided by 10. Then 6 goes into 36 6 times, so 1/6. So k equals 1/6. That means we have m equals to 1/6 E. Or just write as m equals to E divided by 6. Now, what is the moon weight? What is the moon weight? When the person's weight is 186. That's 186 divided by 6, right? 6, that's 1. 6 going to 18, 3, so 31. So if a person is 186 pounds on Earth, and his moon weight is 31 pounds. Because on Earth, because of gravity. Okay, number 8. Number 8 is the last one. Number 8 is saying the water temperature of the Atlantic Ocean, so temperature, varies inversely as the water depth. So let's make this depth variable D. Let's make this temperature capital T. So that means T varies inversely, K divided by D, right? Or K equals to T times D. At a depth of 1,000 meters, so that means D equals to 1,000 meters. Then the water is 5 degrees Celsius. So the water is, the temperature is 5 degrees in Celsius. So K equals to 1,000 multiplied by 5, which is 5,000. Right? So we have our formula T equals to 5,000 divided by the depth T, D. Okay, question. What is the water temperature at the depth? So what is T at the depth of 5,000? Or the coincidence, we have two 5,000, right? K equals to 5,000. And now the depth is 5,000. 5,000 divided by 5,000 is just 1. So when the depth of water is 5,000 meters, the temperature is 1 degree in Celsius. All right, that's it. That's today's lecture notes. All right.